Click the bell icon to get latest videos from Ekeeda.
Hello friends, so now we are going to see a problem based on traveling salesman. Now this is the most noted problem in assignment where there is a salesman who has to visit multiple locations in such a manner that he has to return to the same city from where he started. Now this becomes a tricky one, because this needs a lot of logic and a lot of calculations. The whole calculations are very tricky, so we'll just follow a problem. At the initial stage we are going to follow the same method or the same steps that we follow under a normal assignment problem, but at the later stage we need to just check certain conditions and try to improve the solution to get a best one. Let's note down a problem. Now, I have written a traveling salesman problem where we have 5 cities A, B, C and D, and we have a salesman who has to cover all these 5 cities. Now these 5 cities should be covered in such a way that he should return to the same city from where he has started. So imagine a salesman starts on day 1 from city A. He has to cover all the other cities B, C, D and E, and then only he can return back to A without going to any other cities. That way he has to cover all the cities in any sequence before coming back to the city from where he has started. Now this is a problem not exactly of assignment, but then we can use assignment as the initial step to get a solution for a traveling salesman problem. Let's see what can be done and how a problem can be solved. Our first step will be to check problem should be of minimization and it should be balanced. In case of traveling salesman, almost in all the cases, in 100% all cases, the problem will be balanced because the number of cities will be always equal. In both the rows and the columns we have the same cities. Second, it should be of minimization. This is a minimization problem and it is balanced, so I can directly proceed to row minima, then I'll go for the column minima and checking the optimality test. Let's see. The problem is of minimization. And second, the problem is balanced. So I can proceed further and go for directly row minima. My first step. In my first row, I have the lowest number as 1. So 2 minus 1, 5 minus 1, 7 minus 1 and 1 minus 1. So in my second row, the lowest number is 2. So 6 minus 2 it will be 4. 3 minus 2, 1, 8 minus 2 and 2 minus 2. In my third row, my lowest number is 4. So 8 minus 4, 7 minus 4, 4 minus 4 and 7 minus 4. In my next row, that is the fourth row, I have the lowest number as 4. So 12 minus 4, 4 minus 4, 6 minus 4 and 5 minus 4. And in my last row, I have 1 as the lowest number. So 1 minus 1, 3 minus 1, 2 minus 1, 8 minus 1 and dash. Now after row minima, I will go for column minima. Under column minima, we select the lowest number in each column. In my first column, I have the lowest number as 4th. I will subtract from all the numbers. In the first column, I have the lowest number as 0, so I will note down the same column as it is. In the second column, again I have the lowest number as 0, I will note down the same column as it is. In the third column, we have 1 as the lowest number. So I'll subtract 1 from all the elements of the column. And in the fourth column, I have 0 as the lowest number. And in the last column, again, I have the 0 as the lowest number. So the fifth and the fourth columns will remain as it is because they have 0 as the lowest number. So it will be 4 minus 1, 1 minus 1, 2 minus 1 and 1 minus 1, and the rest of the numbers shall remain same. Now after column minima, my next step will be to check the optimality test. So let's rewrite the whole table and check for the optimality. Now I'll go row wise and column wise and check the position of the zeros for drawing the lines. Lines can be drawn as earlier vertical or horizontal, no diagonal lines, and minimum lines में सब zeros cover करना है. Let's see the position of the zeros first. So I have 2 zeros in the last column. I have 2 zeros in the last row. Then I have 3 more zeros which are in separate columns. So there's no option but I have to draw 3 more lines, 1, 2 and 3. So my number of lines are 4. Number of lines to cover all zeros equals to 5, and number of rows and columns are also 5. Therefore solution is optimal. Now we will look at the final solution by assignment method. So now comes the next part, that is allocation. I have just rewritten the whole table as it is. Now we'll go for the allocations. In the first row, I have got only 1 0. So I'll cancel all the zeros in the corresponding column. In the second row, again I have only 1 0. I'll cancel all the zeros in the second column. In the third row, I have only 1 0. I don't have any other zeros to be cancelled. In the fourth row, again I have only 1 0. And in the last row, again we have only 1 0. Now how is our allocation? I am going from A to E. As I told you earlier, under a traveling salesman problem, I need to start from one particular city and I need to come back to the same city again. But before coming back to the same city, you have to assure that you have traveled all the other cities given in the problem. Now let's see if this condition is satisfied. A traveling salesman problem is not exactly an assignment problem. What we have done at the first stage is we have obtained the initial solution by Hungarian assignment method, but then is this solution satisfying all the conditions of a traveling salesman problem? Let's see. आई एम गोइंग फ्रॉम ए टू ई, तो सेल्समैन आपका ए से ई जाता है और फिर वो ई से ए पे आ जाता है। एंड अनदर रूट वी हैव is salesman start from B to C, C to D, and D to B. In both the cases, the basic conditions that all the cities should be covered before returning back to the place from where you started is not satisfied. फर्स्ट केस में मैंने सिर्फ 2 ही सिटीज कवर किया, ए और ई। सेकेंड केस में मैंने सिर्फ 3 ही सिटीज कवर किया, दैट इज बी, सी एंड डी। Therefore, I need to improve this and do something that will improve the solution. Now, what can be done? We need to check for both the cases, and out of the two, whichever will give me the lowest cost will be the optimal solution. हम पहले B, C, D back to B solution को improve करते हैं। Now I started from B as the route suggests. I go to C first. So this is my first allocation. So I'll cancel all the zeros in that particular column. From C I go to D. From C I go to D. And then as per the assignment, I come back again from D to B, which is not allowed because still I have got 2 more cities to cover, that is A and E. मैंने B से C, C से D और D to B की जगह पर मुझे कवर करना होगा D to A और D to E। अब देखिए, हम लोग जा रहे थे D to B, which is not possible. This is not possible because it won't satisfy the condition of covering all the cities. So what I can go for then? I can go for D to A or D to E, either of the two. अब मैं D to A जाऊंगा तो 8 रुपए है, D to E जाऊंगा तो 1 rupees है, which is the cheaper one. दोनों में से सस्ता कौन सा है? D to E. तो I'll go for E. तो उस कॉलम के करस्पॉन्डिंग जीरोस कैंसिल हो जाएंगे। अब मुझे E से जाना होगा कंपल्सरी एट A. E to A, again there is a zero. So I went from B to C, C to D, D to B आ रहा था मैं return as per the original solution, but I can't go to B. I have to go to either A or E. Out of the two, E is the cheaper one, so I went from D to E, and from E I came back to A. Now check whether all my cities are covered. B, C, D, E, A, all cities are covered. Now I can come back to again B. A से मैं चला जाऊंगा B पे. This way I have improved the solution and added 2 more cities E and A in my original solution. Now let's check the solution first. So B to C, C to D, B to C, C to D, then it is D to E and E to A, D to E and E to A, and finally from A to B. So my cost will be B to C, it is 3, C to D it is 4, D to E it is 5, E to A it is 1, and A to B it is 2. So my total cost will be 3, 7, 12, 13 and 2, 15. So as per the first improved solution, I can get a cost of 15. Now let's try to improve the other route. Can I obtain the solution by using this route? Let's see. So now we are trying to improve the other route, that is A to E and E to A. Now first I'll go from A to E. I'll cancel all the other zeros. From E I can't come back to A because I need to cover all the other cities. मैं E से वापस A तक नहीं आ सकता हूँ क्योंकि मुझे बाकी cities भी cover करना है. And which are the remaining cities? B, C and D. तो B, C and D में the cheapest one with the lowest number is 0. So I'll go to C. अगर मैं C के पास जाऊंगा तो उस कॉलम के बाकी zeros cancel हो जाएंगे. So I went from A to E. From E I didn't wait to A, I went directly to C because I want to cover all the cities. Now from C I have to cover two more cities, B or D. B 3 rupees, D 0 rupees. So D is the cheaper one. So I will cover D, and from D I have to cover B, and from B I can be back to again A. So I covered all the cities before coming back to A again. So you can check out A to E original solution. फिर E to A हम नहीं जाएंगे क्योंकि हमको जाना था B, C नहीं तो D. हमारे लिए चीपर ऑप्शन था C. हम C के पास गए. C से हमें जाना था B नहीं तो D. चीपर वॉज D. हम D के पास गए. D से हमें जाना था B के पास, 0 था वहां पे बेस्ट ऑप्शन. एंड देन B से हम लोग बैक टू origin from where we started, A के पास आ गए. Now what is my final solution? Let's refer the original question. Now this is my second route. It is A to E. So A to E, E to C, E to C, C to D, C to D, D to B, D to B, and B to A, B to A. What will be the cost? It will be 1, 6, 4, 4 and 2. Total traveling cost will be A2 is 1, E to C is 2, C to D is 4, D to B it is 4, and B to A it is 6, which comes to 10, 14, 15, 16 and 17. So what we have done, we have obtained an initial solution by Ham method, and then at the second stage we improved both the routes that are obtained by the assignment method. दोनों रूट में से ट्रेवलिंग सेल्समैन प्रॉब्लम को सॉल्व करने के लिए हमें पहला वाला रूट चीपर लग रहा है 15 रुपीस. Therefore optimal solution is the solution with lowest cost. Therefore, total cost will be rupees 15 and the schedule or the route will be B to C, C to D, D to E, E to A, and back from A to B. He can start from anywhere, he can start from B, he can start from A, he can start from any of the cities. So if he is located at A, he will start from A to B, B to C, C to D, D to E. Or if he starts from E, he can start from E to A to B, B to C, C to D, D to E. So technically it doesn't really matter at which city is located. You can start from any of the cities and cover them in this most optimal way. This is the most typical problem under assignment, that is a traveling salesman problem. But chances are very less that something like traveling salesman problem might be asked in the exam. I hope you got this point. It's highly logical. The last part especially is logical, where you need to just improve the solution to cover all the cities. And you'll always have two alternate routes covering different cities, and both the routes should be improved, and one which will give the lowest cost will be the optimal one. Hope you got the point, friends. Thanks for watching this video. Do subscribe to our channel Ekeeda.